Hello everyone, thank you for clicking on the video. Today we're going to be solving some more calculus problems. These problems are going to have to deal with exponents, and we're going to be looking at more of whether these functions are even or odd, and what their graphs look like. So before we get started, I do want to say that with these types of problems, the more you practice them, the better you will be. There are a lot of rules that you're going to have to remember, and there's no way to get over that. You're just going to have to keep practicing and keep remembering all these rules. So let's get started here with number one. The question asks, it is known y varies inversely with the cube root of x to the fourth power. Given y equals 2 when x equals 8, write y as a power function of x. So since it says varies inversely, that means that we know the x part of the function is going to be, we're going to put that in the denominator. If this were to say directly varies or varies directly, then the x portion would be in the numerator. But since this says inversely, we're going to leave that in the denominator. It's saying the cube root of x to the fourth power. Now, when I first read this, I wrote the function like this: y equals k over cube root of x to the fourth power. So before you get started on these problems, if you're taking a quiz or anything, just ask your professor or teacher just to make sure you have the correct equation. The wording here is a little vague, so just be mindful of that. So we know that there's going to have to be some constant k that we're solving for. So if y equals 2 and x equals 8, we can set up the formula as 2 equals k over the cubed root of 8 to the fourth power. So 2 equals k over 2 to the fourth. That's we eventually get k equals 32. So the function as a power of x would be y equals 32 over the cubed root of x to the fourth power. Number 2 is similar. We have you are told y varies directly as the cubed of x and inversely as the square root of z. So since y varies directly, x is going to be in the numerator, and inversely for z, it's going to be in the denominator. So we have the function y equals our constant times x cubed over the square root of z. So we also have if y equals 16, x equals 2, and z equals 9, then find y when x equals 3 and z equals 4. So now that we have our equations set up, we can plug in all the variables that we do know to solve for k. So we have 16 equals k times 2 to the third over square root of 9, and eventually we get k equals 6. So once we have k, we can rewrite the function as y equals 6 x cubed over the square root of z. Next, we plug in the values that they gave us for the missing y, and we have y equals 6 times 3 to the third power over the square root of 4, and that comes out to y equals 81. Okay, for number 3, we're asked to mark each statement as either true or false. As you can see, I've went ahead and also written down the properties or the rules that correspond to these types of problems. So again, with these types of problems, you're only going to get better if you memorize these and if you practice them. The more you practice, the more you'll be able to recognize them. So let's start with this first one. X to the 1/3 equals the cubed root of x. So as you can see, I've written down this rule here: x to the a over b equals b root of x to the a. In this case, our a would be 1 and our b would be 3. So we would write that as the cube root of x to the 1 power. So this would be true. Next, we have x to the 5th, and then we have parentheses squared. So whenever we have something like that, the rule is you have x to the a, parentheses to the b. We are just multiplying these two values. So we get x to the 10th, since we have 5 and 2 here, so this would be true. Next, we have x to the negative 2 power equals negative x squared. So this is not correct, because if you look at this rule, x to the negative n equals 1 over x to the nth power. So this is an inverse function, so we're actually going to have, so this is going to be false, but the correct expression would be 1 over x squared. Next we have x squared times x to the third equals x to the sixth. The rule for these types of problems is x to the a times x to the b equals x to the a plus b. So we would get false for this one, and the correct expression would be x to the fifth. We would take 2 and 3 and we would add them together. Next we have x to the sixth over x squared equals x cubed. So the rule for this one would be x to the a over x to the b equals x to the a minus b. So this would be false, and the correct expression would be x to the fourth. We would take 6 and subtract 2, just like the rule says here. The last one is the same as the rule for the first one. So x to the a over b equals the b root of x to the a. So in this case, our b would be 3 and our a would be 2. So we would get x to the 2/3. So this is true. So for number 4, we're simplifying these exponents. Again, you're just going to have to memorize the rules and practice these. So what you could do is go ahead and solve these with me walking you through it, and then try again. Try all of these problems again on your own without looking at the answers, and see if you remember them, and just try that a couple times. That's the best way that it works for me. But anyways, we have here 2b to the fourth, and then we have parentheses to the third. So we're going to be using this rule here. So we're going to distribute this 3. So we're going to have 2 to the third power, and we're going to have b to the 3 times 4. So we're going to get 8b to the 12th power. For this expression, we have 3 over x squared y, parentheses, squared. So again, we're going to distribute this 2 to each of these terms. 3 squared over x, and then we're going to distribute this, so 2 times 2, and then y is going to get the squared. And simplified, this would be 9 over x to the fourth y squared. 5a to the fourth times b, parentheses, squared. So we're going to distribute to each term. We have 5 squared, a to the 4 times 2, and b squared. So we're going to have 25a to the 8th b squared. This next one, we're going to be distributing this 4 to each term again. So this would be m to the 3 times 4 over 2 to the 4th, and then n to the 2 times 4. And this simplifies to m to the 12th over 16th times n to the 8th. Here we have negative 2 times a times b to the 4th, parentheses to the 4th. So again, we're going to be distributing. So we'll have negative 2 to the 4th, a to the 4th, and then b to the 4 times 4. We're going to have 16, a to the 4th, b to the 16th. Another distribution, we have negative 2a squared over b squared, to parentheses to the third. We're going to distribute that 3, so we're going to have negative 2 to the third. We're going to have a to the 2 times 3, and we're going to have b to the 2 times 3. So this simplifies to negative 8, a to the 6th over b to the 6th. So here we have a negative power, so this means that this is an inverse function. So what I like to do first is get rid of this negative exponent. So we can rewrite this as 1 over all of this squared. And then we can start the distribution. We'll have 1 over 4 squared, a times 3 times 2. A to the 3 times 2. And we'll have 3 squared and b squared. And since you're dividing in the denominator, we can flip these terms around, and this will be 9b squared over 16a to the 6th. And this last one, we're distributing this 2. We have negative 3 squared, p times to the 2 times 2, and q to the 3rd times 2. So this simplifies to 9, p to the 4th over q to the 6th. Okay, so for number 5, we're asked to cross out every function below that is not a power function, given that c, g, k, and pi are all constants. For the power functions that aren't crossed out, rewrite the constant variation under the function. So a power function is just when we have a variable and we are raising it to a certain power. and nothing else. So we can't have any additional things. It's just the variable raised to a certain power, and we are allowed to have a constant. So for this first one, we have negative 2 x to the fifth. So our constant here would be negative 2. We don't have any other terms, just negative 2 x to the fifth. So our constant would be negative 2. V equals 4/3 pi times r cubed. So here r is getting cubed, so our constant would be 4/3 pi. These are both numbers. So our constant here is 4/3 pi. F of x equals negative 1/2 times the square root of x. The square root of x is really x to the 1/2, so our constant here would be negative 1/2. Next we have f of x equals 9x to the 5/3 power. We don't have any other terms, so our constant here is 9. F of x, we have x to the negative 2 power, so our constant would be 3. Here we don't have a term to a power, but we would still write 13 as the constant. At every x value, the y value would be 13. Now here we have Einstein's equation equals mc squared. But here, since it's saying e of m, we know that the variable here would be m, so our constant would be c squared. So our k equals c squared. Then we have ke of v, so we know that v is our variable. K is a constant as said in the instructions, so our constant would be 1/2 k. I'm missing a k here, but that would be 1/2 k. For f of x, we have 2x squared times 4x cubed. So this can be simplified further. We will have 8 times x to the 6th. For g of x, we see that there's one term to the 5th, and then we're adding a second term. So this would not be a power function since there are multiple powers. So we'll cross this out. Next, d equals 1/2 g times t squared. So we know that g is a constant. It was said here in the instructions. So our constant here would be 1/2 g, and t is getting squared. So we would write k equals 1/2 g. Next we have v equals 4/3 pi r cubed. This is the exact same question as the one over here. So again, our constant would be 4/3 pi. Next we have f equals ma. Now if you notice, we don't have a parentheses on this function, so we don't know which of these variables is the actual function that is raised to a power. So we can't say that either one of these are constants, so we'll just cross this out. For h of x, we have two terms, we have additional things, and the powers are different, so we'll cross this out as well. And finally, we have 1 over k over d to the 5th. We know that k is a constant from the instructions, so we'll write the constant is k. Okay, so for number 6, we're asked, without graphing, label each of the power functions below as even, odd, or neither. So I've went ahead and written out these rules here. Again, these are just some rules that you're going to have to remember and practice. So I have even is when we'll have an even function when the numerator is even. We'll have an odd function if the numerator and the denominator are odd. And it's neither if the numerator is odd, but the denominator is even. So looking at this first one, y equals x to the negative 4 over 3. So we can see that our numerator is even, our denominator is odd, so we would write that this function is even. We have y equals x to the 10 over 3. Again, our numerator is even, so this function would be even. Next is y equals x squared. This is even. Next we have y equals x to the negative 3 over 5. So both of these, the numerator and the denominator, are odd, so this function would be odd. Next we have y equals x to the 3rd over 7th. So both terms are odd, the numerator and the denominator are odd, so the function would be odd. This next one is the same. We have y equals x to the negative 5th over 3. Both numerator and denominator are odd, so the function is odd. For y equals x to the 2 over 3, the numerator is even, so the function would be even. Y equals x to the negative 6 over 5, numerator is even, so the function is even. Y equals x to the negative 4, that's an even, so the function would be even. Next we have y equals x to the 3 over 2, so the numerator is odd and the denominator is even, so this would be neither. Next we have y equals x to the 5 over 2. Again, the numerator is odd, but the denominator is even, so this would be neither. Finally, we have y equals x to the 8 over 3. The numerator is even, so the function would be even. For number 7, we're asked to sketch the graph of f of x equals x to the 5 over 7, and then evaluate each limit shown. So if you have a calculator, I would suggest going ahead and graphing this out and basically just copying what you see on a calculator. If you're not allowed to use one, like on a test or a quiz, then you're just going to have to remember what these types of functions look like. So in this case, both the numerator and the denominator are odd, so we know that the function will be odd at the very least, and it is less than 1, so these types of functions look more or less like this. Next, we're asked to evaluate the limits. So if we look at 0 from the left, it looks like these y values are approaching 0. If we're looking at 0 from the right, these y values are decreasing and they're also approaching 0. Next, we're asked the limit as x approaches negative infinity. So as x goes on, these y values are going to be decreasing. So that's going to be negative infinity. The limit as x approaches positive infinity, these y values are going to get bigger and bigger, and so the limit would be positive infinity. So this next one, sketch the graph of f of x equals x to the 8 over 3. So it looks like the numerator is even, so this would be an even function. So it's going to look more or less like this. So the 0 from the left would be 0, 0 from the right would also be 0. The limit as x goes to negative infinity would be positive infinity, and as x goes to positive infinity, the y's would also go to positive infinity. Finally, for these sets of problems, we're asking two questions. So the directions say each graph below contains a power function, and the line y equals x for reference. So which function cannot be the one shown to the right? Two questions we have to ask ourselves for these types of problems. We have, is the exponent less than or greater than 1? And is the function even or odd? So as we look at these groups of functions here, the first thing we notice is that they're all even, the numerators are all even, but if we look at whether or not the exponents are greater than or less than or greater than 1, we can see that d here is greater than 1, 6 over 11 is less than 1, 2/3 is less than 1, and 4/5 is less than 1. So it's safe to say that our answer here would be D, x to the 4/3. Another thing you can do is if you're not sure and you are allowed a calculator, you can go ahead and plot all of these onto your graphing calculator and look at which function is different. So I'm going to show you an example of that. So for that problem, our first equation was x to the 2/3. Make sure that you do have these parentheses up here when you're typing it into your calculator. That's very important. Our second equation is x to the 4/5. Third equation was x to the 6 over 11. And our last equation was x to the 4/3. So once we hit graph, we'll let our calculator graph this. You can see here the blue line is going to be the first equation, the red will be the second, and the black will be the third, and the pink will be the fourth equation, which we said was the answer to that first question. So already, as you can see that while this calculator is graphing these functions, All of these graphs, the lines are kind of concave up away from the x-axis. So you see they kind of have this like bent shape to them. But then when we look at that fourth function, it looks like it's bending towards the x-axis, not away from it. So that's another indication that that would be our answer. Again, if you do have a calculator, you can try this out, and you can see which function is different from the rest. The next one is which function cannot be shown to the right. So again, we can see that all of these functions are even. So let's see which of these functions is less than, or which of these functions is different when it comes to if the exponent is less than or greater than 1. So for the A, we can see that 4/3 is greater than 1, B, 4 is greater than 1, C, 2 is greater than 1, but for D, 4/5 is less than 1. So we would choose D as our answer. Number 11, let's look at whether the function is even or odd. So it looks like in the numerator, all of the numerators are odd, so these would all be odd functions. So let's ask ourselves if the exponents are less than or greater than 1. So A, 3/2 is greater than 1, but the rest of these, the exponents is less than 1, so A would be our answer. Finally, we're doing the same thing here. All of these functions are odd, but this B function is even. So you see a 7 in the numerator here, 5, and a 13. But for this B function, we have a 4, which would make this function even. So B would be our answer. So that does it for this video, guys. With these types of problems, I would suggest a lot of practice, memorizing all the rules for exponents, trying these problems again by yourselves without the answers, just memorizing and practicing. That is the key to these types of problems. And I promise you that they are not going away. You will see them in almost every single higher level math class. So thank you for clicking on the video. If you found this helpful, please like and subscribe. It really helps the channel out. And I'll see you in the next one.